Okay. So anyway, small magnetic loop antennas, and I'm going to focus on this antenna, which is one that I constructed. I'll bet you there's less than $10 in materials here. This is just PVC that I painted black. This is just some coax, and there's a variable capacitor in here, and this little strip of aluminum for the coupling loop. I'm going to talk about how to build them, and hopefully, if you don't have one in your shack or in your toolbox, I really encourage you to go home and build one of these, because it's a great little antenna to have around. In fact, I told Dan, if someday I, am retired and don't have the property that I have now for my antennas, and I'm in a restricted space, I'm absolutely going to make sure I have one of these loop antennas, because you can work the world on it with something this small and from indoors. So very quickly, I'm going to talk a little bit about the theory of these antennas tonight. I'm going to talk about how to build your own, some of the advantages and disadvantages of a loop antenna versus some of these portable whips. And I have a couple of these hooked up to some QRP radios that you can play with as well as soon as I finish. So a magnetic loop is a little bit different than a typical dipole or even a vertical antenna with a ground plane, because it relies on the magnetic side of the electromagnetic wave to induce a current in the outer loop. So we're sending voltage up to this small loop, and you can see there's no electrical connection between the small loop and the big loop. It's relying on the magnetic side of the RF wave to induce a current in the outer loop, which then radiates at a tuned frequency. And the tuning magic happens with just a single variable capacitor at the base of the outer loop. So this antenna, believe it or not, this tiny little thing will tune all the way down to 40 meters. Now, it has a high Q factor, which means a very narrow bandwidth, but it will tune. And if you have the patience to tune it and get it onto the frequency that you want to work, it's a great option for QRP operations. So in my case, this particular antenna is actually just made out of a piece of shorted coax. So I have the shield and the center conductor shorted to get as much surface area as I can. People use aluminum tubing. In fact, I've seen like in auto parts stores for like fuel lines, people will use flexible aluminum tubing for their antennas. In fact, I'm going to share a design with you of a guy who built a loop antenna by putting aluminum furnace tape on PVC, and it works. So the bottom line is the more surface area you can get for that outer loop, the better. In my case, this coax works just fine. This is all collapsible, so I can pull apart these little PVC connectors and break this down and then take it for portable operations. And you'll see on the front of the antenna, when you come over and look at it, there's a little tuning knob for the variable capacitor. And the variable capacitor itself is probably the most expensive thing you're going to have to buy for this antenna. And good quality variable capacitors can be a little expensive. I think the one I have in here, I salvaged. I had ended up with a whole bunch of them that Dave and I, K8KJR, we actually scavenged from some guy that collected receivers. He had a whole bunch of vintage receivers, and his son was trying to get rid of them. And we said, well, can we just pillage the capacitors out of them? So we got about 20 of them out of that. If you need one, let me know. And then, of course, you'll need to solder the components together. So here I'm just using a cross-shaped frame, and the outer loop connects to the two sides of the variable capacitor, and then the feed line connects directly to the coupling loop, which is the smaller loop. And in this case, I'm using a BNC breakout. I don't know if you guys have seen these. They're really great. You can build dipoles and all kinds of things with these, but it just has two little banana plug post connectors, and and a BNC connector for the feed line. So this is a really good, it's kind of a maybe hard to read, so we'll send out the presentation to everybody, but this is a really good diagram of how these magnetic loop antennas work. So you can see the variable capacitor, in this case, at the top of the loop. The coupling loop is at the bottom, connected directly to the feed line. In fact, there's actually a schematic on the left showing the inductance of the outer loop, which, by the way, I'll just mention quickly, the outer loop is naturally inductive, which is why we have to introduce capacitance to the circuit for tuning. And there's the coupling loop on the right-hand side. There's a little image of the radiation pattern on these as well, which, by the way, are directional. So when you're working in portable operation, for example, just turning it one direction or the other will make a perceptible difference, and you can null out signals as well using its directionality. Now, this is the one I was telling you about that's built out of PVC and furnace tape. And I don't know if I have his call sign on that image or not, but the guy that built this swears by it. And essentially, he built the whole thing out of PVC, wrapped it in furnace tape, and then he uses what's called a trombone capacitor for the variable capacitor, which is just a piece of PVC wrapped in furnace tape and then an aluminum tube that slides in and out. And the more of the tube that's within range of each other's field, the more capacitance you get, or the less as you slide that tube out. So that's an even cheaper way to do it. In his case, he's using a gamma match instead of a coupling loop. So if you can see the little arm bracket looking thing that connects to the feed point, that just taps the outer loop at a certain point to do the coupling for you. So that's another option for building these antennas. This website, 66pacific.com, has really great calculators for calculating the sizes of the outer and inner loops. Rule of thumb is that the inner loop just needs to be 1/5 of the, or 20% of the circumference of the outer loop. So in my case, this outer loop is maybe, I guess, probably 6 foot long, the coax, and this is 1/5 of that length, and this works all the way down to 40 meters. Pretty remarkable, actually. So you can use this website to calculate it. You can tell it what your optimum frequency is that you want to use, and it'll tell you the best size of the outer loop, and then you can calculate the size of the inner loop. It'll also tell you what the maximum capacitance you'll need for your tuning capacitor. Okay, so I've got a couple of neat tuning tricks for these. I can generally tune them by ear. So I just listen for the highest noise, and I know that the antenna is tuned to pretty close at that target frequency. You can also use a manual tuner, though those are not recommended generally for loops because they have such narrow bandwidth, you really need to tune them at the capacitor itself. You can also look at a waterfall display if your radio has it. Wherever you see the noise go all the way up on the waterfall, you know that you're in the frequency range. And then I have this little guy that is a Wheatstone bridge, which is an SWR bridge, but it's one of the little gadgets that I built. And there's just a couple of 50 ohm resistors in there, a diode, a couple of capacitors. And basically what this lets you do is you can switch it into tuning mode. And when you send a carrier to the loop, the LED will light until, as you tune it, the LED will dim. And until you extinguish the LED and it goes completely out, you're off frequency. So once the LED is completely blacked out, your loop is tuned to your target frequency that you're sending from your transmitter. So this is pretty neat, and this actually can just plug right in to the feed point, and I can actually leave this in circuit. And then when I need to tune to a specific frequency, I can just look at this, look at the LED for my tuning instead of even doing it by ear. So those are options that you have for tuning these antennas. This is a schematic of the Wheatstone Bridge, by the way, and this will all be included in my presentation I'll send out to everybody. So here's some of the disadvantages of these. Obviously, narrow bandwidth, as I've mentioned. So anytime that you change frequency, you're going to have to retune it. Even by a couple hundred hertz, you're going to probably have to retune the thing. So just be patient with it. There's actually very high voltages across the capacitor. If I put more than 10 watts of power into this, I'll start to see arcing across the plates of the capacitor. You see little blue lightning bolts start to go across. So it can be dangerous. And I brought this as an example. Tim said this company, Cardwell, was one of the top manufacturers of high quality variable capacitors in the past. And this one is heavy duty. I could probably run 100 watts on this. I don't know, maybe more, Tim? What do you think?
Maybe more.
You think? Yeah. But the danger is always as the electric field, which a capacitor stores an electric field, as that electric field builds, there could be electrical arcing between the plates of the capacitor. So if you wanted to build a loop for higher power, you certainly could do it. Sometimes, there's a little bit of a challenge in building these. You can't be quite as sloppy as with a dipole and just trim it until you get it to where you want it. You really do need to make sure that these loops couple. And you can see this is not a fancy looking contraption, but you do need to make sure the measurements between the circumferences of the two loops are precise so that they optimally couple. Okay. Now, this is the other antenna that I brought that I wanted to showcase. So this is a vertical whip. And the way I built this is modeled after the Sigma Eurocom antenna, which is really just a off-center fed dipole and vertical orientation. It's really all it is. So I have a 4-to-1 unun in this little box here, which connects to this whip. Now, I was at dinner with Barney and Tim last week, and I did this in the restaurant to everyone's dismay. But this is a pretty remarkable extendable whip. Once it's fully extended. See that? I already hit the ceiling. But you'll see this goes this goes all the way to almost 19 feet, 6 meters. Just imagine that in a vertical orientation. That's pretty neat. This I got from AliExpress. Yeah, sorry, Tim. I think DX should start carrying these. They're very handy. And what's cool is you can make a dipole out of them too. So if you have two of them, that's a 20 meter dipole. So no, what's the model number on this? Dan has one of these too. It's tripod based. Yeah, these are available on Amazon. No, it's a 3/8 stud. Mm-hmm. So it goes to the 4-to-1 unun, and then you would run a counterpoise that preferably a tuned counterpoise to the band that you're trying to work. And this is pretty effective, but you really need to be outdoors in order to use it. But these are the I don't know if you can read that, but these are the SWR readings just with the unun itself without an external tuner. So you would need a tuner for 80 meters, 17 meters, 12 meters, and 6 meters. But 60, 40, 30, 20, 15, and 10 you can use without a tuner. Pretty cool.
Wow.
Oh, I could run 100 watts out of this. Yeah.
Do you have any reservations about how low you're running 100 watts? How close to the antenna?
Yeah, that's a good question. Probably need to set this away from you a bit, but yeah. By the way, I use this aluminum table as a ground plane. So it just gives me an additional ground plane. I don't know if you've seen the magic carpet guys that put a aluminum screen down, but this little table actually gives me a little bit more of a ground surface. So I have
Is that a 100-watt sideband or is that a 100-watt digital?
say that again.
Is that 100 watts at sideband or is that 100 watts in other
I would
modes?
100 watts digital, but sideband you probably could, not a problem. So here's a comparison chart that kind of shows the advantages and disadvantages of using these portable whips versus the loop. And I actually have another little show and tell here. This is another little vertical whip antenna system with inductance coils for each band, and they're color coded. So here's 20 meters, and then I cut color coded counterpoise wires that are tuned to each band as well, and that works pretty well, but not nearly as efficient as the loop. Okay. Okay, so anyway, I hope that you come up here and play with some of this equipment. I've got quite a few QRP rigs up here. I've got a little 50-watt amplifier. I've got the True SDX, which is a very well-engineered little project by DL2MAN out of Germany, and a couple of other QRP antennas that you can play with. So anyway, hope you enjoy. Come do the hands-on part now. Thank you.
How far was talking?
Paul.
What's your